Hi friends, in the last problem I have explained you how to calculate or how to determine the coordinates of centroid for a rectangle of width B and D. Now the next question, the second question, I'm going to determine the coordinates of centroid for a triangle. The question is given like this. Show that the centroid for a triangle is located at a distance of h by 3 from the base, where h represents the height of the triangle. So for my convenience, just I am considering a right angle triangle here, capital O, capital P and capital Q. So which has got a base capital B and whose height is capital H. So if I want, I can just change this thing to capital H. Now, to solve the problem, right, just the simple question here is we have to prove that the coordinates of centroid or the location of centroid is exactly at a height of h by 3 from the base. H by 3 from the base. So for this purpose, just I'm assuming that there is a point capital C whose coordinates are x bar and y bar. Now, in the question itself, he asked us to prove that y bar is h by 3. I mean to say this particular distance over here, it should be equal to h by 3. So we have to prove this thing. So in order to prove that y bar is equal to h by 3, the same thing again, I am considering a horizontal strip here, which is small p and q, which has again the coordinates small x and y, where y represents the distance from the reference x-axis. Okay, this is small y, but where exactly are the reference x and y axis? The first step, we have to assume that there is a reference x-axis exactly at the bottom, and I'm considering reference y-axis to the left side of the section. Now when I consider the strip, just I'm neglecting the side slopes, it just looks like a rectangle. I'm just considering the width of the strip as small b. So here it is, small b. And let us consider the thickness of the strip as dy. As you are measuring it in the vertical direction, I'm just considering that one as dy. Same thing again, dy. Now, if I take dA as the area of the strip, dA will be equal to b multiplied by dy. So if capital A is taken as the area of the triangle, A will be equal to half multiplied by base multiplied by height h. So actually we need this formula to calculate the coordinate of centroid. I mean to say the y bar. Okay, the formula here is y bar, which is equal to integral of y dA by integral dA. But here we have the area which is in terms of small b. So we can convert the small b in terms of capital B and H. We can just change them into B and H. So how can we change that one into B and H? It is very simple. So just I'm considering a smaller triangle over here, which is capital O, P and Q, which has got a width capital B, sorry, small b. So this one is a triangle OP and small q. Next, the bigger triangle capital O, capital P and capital Q. The base of this one is given as capital B, and the height of the triangle is given as capital H. Now if capital H is the height of the triangle, the entire triangle, then this value is taken as y. So the remaining distance here, it will be equal to h minus y. H minus y, where h minus y represent the height of the smaller triangle. This is h minus y. Now writing b in terms of capital B and H. So from the law of similar triangle, these two triangles, they just look like similar triangles. So what I'm going to do here is just I'm using the law of similar triangles. From the law of similar triangle, the ratio of base to the height of two similar triangles will be proportional. So I can write small b is equal to b into h minus y divided by h. So I can write this one as b into 1 minus y by h. So I got b, which is equal to b into 1 minus y by h. Now I'm using the formula dA is equal to b into dy. So dA will be equal to b. It can be written as b into 1 minus y by h. b 1 minus y by h multiplied by dy. Okay, now coming back to the original formula y bar, which is equal to integral of y dA by integral dA. Now I can write this thing as y dA, where dA is nothing but b into 1 minus y by h multiplied by dy. b 1 minus y by h multiplied by dy divided by integral of dA. dA is again b into 1 minus y by h. b 1 minus y by h into dy. Now the limits of integration, it will be from 0 to h. The strip, the maximum, to a maximum extent, the strip can move from 0 to h. So the limits of integration will be 0 to capital H. 0 to capital H. Okay, as b is constant, just I'll take it outside. B integral 0 to h y 1 minus y by h into dy by b integral 0 to h 1 minus y by h into dy. So b gets cancelled here. So I can add this thing as y minus y square by h integral of 0 to h dy by integral 0 to h 1 minus y by h into dy. So just integrating this thing, y square by 2 minus y cube by 3h 0 to h divided by y minus y square by 2h 0 to h. So this becomes h square by 2 minus h cube by 3h by h minus h square by 2h. By solving this thing, I can get 3h multiplied by h square. That is 3h cube minus 2h square by 3 2's is 6h by 2h multiplied by h is 2h square minus h square divided by 2h again. So h as well as 3 times it gets cancelled. So we have, this is cube, h cube divided by 3 by 2h square minus h square is h square again. So h square and this gets cancelled here. So we'll get h by 3. So y bar is located at a distance of h by 3. What does that mean? It means centroid for the given triangle is located exactly at a distance of h by 3 from the base. That means this particular distance here. From here, it is located exactly a distance of h by 3. Thank you.